Okay, welcome back to another exam walkthrough. We're going to be going through some questions from, these questions are going to be from 2025 May Unit 5. And then I have some more discussion on a specific topic that I want to do and a few more MCQs on it. Okay, because these questions can be a bit more tricky. So we'll just go through them and I'll try my best to explain it in a very simple way. Okay, so let's go to the first question now. It says in a lab the background count rate is 22 counts per minute. A detector is placed 25 centimeter from the gamma source. The count rate recorded by the detector is 45 counts per minute. The detector is then placed 50 centimeter from the source. So right off the bat, I'm going to subtract the detector, because the detector, it detects both the count rate from the source plus the background count rate. So I want to find what the source is giving me. I don't want the source plus the background count rate. Okay, so I'm going to do 54 minus whatever is coming from the background. That's going to give me 32 counts per minute. Okay, and then what happens is that the detector is and the source, initially the distance between them is 25, and the distance becomes twice of what it was, so it becomes 50. Now, the reason they mention this is because you have to connect this with the intensity. So we know intensity is proportional to 1 by d squared. So let's say in the first case, it was I directly proportional to 1 by d squared. Now what's happening is the d has become twice of the original value. So it's I nu is equals to I, or directly proportional to d 2d square. So it's going to become I is directly proportional to 1 by 4d square. Okay, let's call this I old and I new. So now what I can do, then I can equate both of them with k. Okay, k, where k is a constant. Okay, so I can just multiply both things by above and I can equate them by k. And then I can equate both equations as well, because both of them are equal to k, where k is the proportionality constant. So you notice I equated both of them, cancel the d out. So the new intensity is going to be 1/4 of the old intensity. And so the count rate will also be, the new count rate is going to be the old count rate divided by 4. What was the old count rate? 32. So 32 divided by 4, it's going to be 8. Okay, when I say count rate, I'm talking about the count rate from the source. Okay, not the count rate that you get from the detector, because that's going to include your background count rate as well. So I'm just focusing on the source. So the count rate from the source is going to be divided by 4, and that's going to give me the new count rate at 50 centimeter. Okay, that's going to be 8. But the detector has a problem because it also includes the background count rate. So it's going to be plus 22, and so we should actually get 30 counts per minute. That's going to be the new one. Okay, so I've taken into account both the distance and the background and everything, and I've got my answer as 30. And if you actually calculate all the values from here, you should get the answer as B. Alright. Okay, so now we're going to be talking about the intensity and thickness. So when I say thickness, what the scenario will look like. So this is our setup. We're going to have the Geiger counter. We're going to have the LED box, within which we're going to have our gamma source, and then we're going to have our distance there, the sheet. Okay, so we can change the thickness of the sheet. So right now there's a 3mm aluminum sheet in this diagram, so we can change it up and do that. And then what we did in the previous experiment, in the previous example, was we changed the distance, and that affected the count rate. So I just want to make one more comment on that, is intensity is inversely proportional to distance squared. You can also just make a direct relation of that the count rate from the source is directly proportional to, inversely proportional, my bad, for both of them, inversely proportional to distance squared. So you can make that relation for both of them, inverse square relation. Okay, so you can write this down in your notes if you did not know. So in the last question, previous MCQ, we changed the distance. In this one, we're changing the thickness. Okay, and when you change the thickness, it follows this relation right over here. I is equals to I naught E minus mu x, where x is the thickness, I is the intensity. And so what I want to talk about specifically is the half thickness or half value layer. In Excel they call it half thickness, so I'm just going to use that language here as well. So half thickness. So half thickness means the thickness of material needed to reduce the intensity to half, and this is an exponential relation. Just how we have half-life, so we also have half thickness. Half-life, half thickness is kind of similar concept, okay? So I want you to just keep that concept of half-life in mind when you go in this as well. So at a specific thickness, your intensity will reduce to half. That will be the half value layer or half thickness. So let's say that value is going to be 5 centimeter. So you're going to have I naught 0.5, okay? And then if you add another 5 and it goes to 10 centimeter, then it's going to become 0.25 I naught. If you add another 5, 15 centimeter, 0.125 I naught. Okay, so the first half thickness is going to be 0.5 I naught. Second half thickness is going to be 0.25 I naught. And the third half thickness is going to be 0.125 I naught. I hope that's clear. You can continue this as well. Alright. And I have some notes as well. You can just read through this, okay, for your concept. So please do read through this. Pause the video, read through this, and then I will answer 3 MCQs related to this. So here's the first question, one, and this one is from 2025 May. So this one's a new one, but it's the same concept, okay? So it says a student used a detector to determine the intensity of radiation from a source of gamma radiation. After correcting for background, the intensity of radiation was required to be I naught. A sheet of 2.5 centimeter was placed, okay, and then the intensity was now 0.5 I naught. So 2.5 centimeter causes our intensity to become 0.5 I naught. So this is going to be the half thickness, the first half thickness. The second half thickness is going to be 5 centimeter. So it's going to become 0.25 I naught. And the third half thickness is 7.5 centimeter, and that's what they've given in the question. And then the intensity is going to become 0.125 I naught. So the answer is going to be C, because if you round this, it's going to be 0.13 I naught. Okay, I've done this a little quick. Okay, so I hope this is clear. And I have 2 more MCQs as well. So this from 2023 Jan Unit 5, 2020 October Unit 5. Okay, here one again, they have told me that 0.8 centimeter is going to be 0.25 I naught. So this is going to be the second half thickness, right? This is going to be the second half thickness. Okay, so what we want to do here is we want to find the first half thickness. So we want to find the 0.5 I naught. Okay, so remember, for every x thickness, we don't know what this x is, for every x thickness, the intensity will become half. Okay, so initially it was some x and then another x, so plus x, and you get 0.8, right? I don't think this is the best example to explain this. So for example, it was 0.2 example. Okay, think about it as 0.2. So you got 0.5 I naught, and the second half thickness was 0.4 and 0.25 I naught. So this was x. That's what I'm trying to say. There's an x value here. I don't know what it is. And then x plus x gave me this value. Does that make sense? Okay, so x plus x gave me this value. So every x, your intensity will reduce by half. That's what I'm trying to say. So x plus x should be 0.8. So 2x should be 0.8. You're going to get x as 0.4. So I just wanted to do it a bit more systematically. And the answer here will be 0.4. Okay. The next one is this. The student discovered that the thickness of 1 centimeter of lead reduced the corrected counted to 50%. So our half thickness is 1 centimeter, which reduces the intensity by 0.5 I naught. First two options are wrong, okay, because you can't make this a linear relationship that, okay, this applies for 0.5 as well, right? Because half thickness, we're only talking about half thickness, we're not looking at anywhere else, okay? So first two are wrong. So the third one is the correct option because every 1 centimeter the thickness should halve, so it should be 2 centimeters equals to 0.25 I naught. So that's the correct answer. Okay, let's move on to the last question. I'm not going to read this, it's going to take a lot of time, just read through it quickly. I've done this exam walkthrough of the same type of question before as well. So the answer to this question is that the student has really wrong statements here. It says alpha particles are thick because, no, alpha particle tracks are thick because alpha particles are massive. That's wrong. It's because of their ionizing ability. And then the tracks are straight because, now basically the student has swiped the statements. It should be the other way around. And in the next part, beta particles actually don't have similar ionization to alpha particles. Alpha particles have more amount of ionization because alpha particles have more charge than beta particles. And then it says beta particles are thin, tracks are thin and twisted because they have much less mass than alpha particles. Well, here you can see it's kind of correct because it's saying that the tracks are twisted because of the less because they're less massive than alpha particles. So that's true. Okay, so you'll get I'll tell you the points that you can get. So number one, I mentioned here that alpha particles have low ionizing ability, so that's why they have thin tracks. And I criticize the student's statement that the student is wrong, so I get 2 marks for that. One is just writing the correct thing and then criticizing the student. And then just for correcting the alpha particle statements, you get the rest of the 2 marks as well. And there are obviously other marks as well. I'll show you the mark scheme.